Welcome, everybody. How y'all doing? Oh, come on. That's. We just gave you alcohol, people. It's like, I expect enthusiasm for beer. I'm picky about that. And when we amp the level and we actually give you oysters, I mean, geez. I have to admit, I was a little dubious about the oysters. It's like there's just something seems wrong about oysters out of a truck in the back parking lot. I don't know. How many people are doing the oysters? Oh, yeah. See, at least a few of you are like, I'm going for it. Oysters. I'm personally not an oyster guy to begin with, so that's okay. I'm fine. So in case you haven't guessed, we will be doing the vast majority of this presentation in English for many reasons. The most important one being that we are streaming all of this live, as we always do, around the world. So at this point, many people on the East Coast, West Coast, and a few hardy souls in Europe and Asia are probably watching us. Very hardy if they're in Asia, because I think it's about 3 in the morning right now. They really love these shows if they're watching. Thankfully, we record this and it's all available. So if you miss something, you fall asleep somehow in the middle of the presentation, you'll have something to watch later when you come back. So, as I said, we'll be doing this presentation in English. The secondary reason for that is I am not very fluent in French whatsoever, and my jokes will fall flat in another language, absolutely. Well, they fall flat in English an awful lot, but then it'll be worse in French, trust me. So what we're going to do is we're going to start off first with a little play down of a show reel. There's this little thing called Game Developers Conference going on the other coast right now. Thanks to you guys, I got out of doing a trade show and I'm here instead. And this is my first year in 15 years I have not been at GDC, and I thank you. Thank you. Thank you very much. So we did just finish creating the latest game show reel. One of the guys on my team, Alain DeRocher, and some freelancers spent a whole bunch of time putting together some show reels. This is some of the best work submitted to us from games clients all over the world. Awesome little reel, and check it out. It continues to boggle my mind how hard it is getting these days to be able to tell the difference between a rendered cinematic and the in-game stuff. It's just, it used to be, it was like cinematic, in-game, cinematic. You just knew. Now it's, that line is getting really blurry. So, in case you didn't know where you were at the Unfold event. In this particular event, we're going to be doing a number of things, and I will show them to you now. First, there's me, speaking randomly. It's my job to stand up here and say whatever comes to my mind, because I didn't have any time to rehearse any of this, because I was doing other stuff all the rest of the day. But basically, we're going to be going through a number of things. We're going to go through first a guest presentation. You'll definitely want to check this out. How many people here have seen the animated short Natalis? A few hands go up. Some of you have probably seen it and just don't remember it by name. Won a big award at the VES Society. We're going to be looking at that short and checking out how that was made. We're also going to go to one of the things I'm sure many of you have showed up for, which is the new product demonstrations. How many people here came to see that? Let's you. No, I just came for the beer. That's what I'm here for. Yeah, see, there's... Wait a minute, you're my speaker. It's like, I came for the beer, dude. That's all I'm interested in. So we're going to do new product demonstrations, and after that, we're going to have an industry panel. We're going to be talking to a bunch of industry veterans that come from various areas, games, film, TV. I've worked in a lot of places, and we're going to talk a little bit about the state of the industry today. I think that should be interesting. And from there, we go on to Eat, Drink, and Be Merry, which is always the best part of any event. And I'm sorry to everyone online who is watching. You're just going to have to buy your own alcohol and eat your own oysters. I hope you're prepared. Oysters aren't so easy to come by at the last minute. So before we get into the presentation, though, I'd like to continue speaking randomly for just a little bit longer. Anyone that wants to get a little more information on what's going on with our products, we have videos up on the area. Some of you have probably already seen them. You can learn a lot more details about what's been going on in the products there. We also have put all the videos on YouTube for people who prefer to watch things on YouTube in some sort of playlist fashion. A number of them are also on Autodesk.com. You can't say we didn't give it to you in as many possible flavors as we could. But one of the big conversation topics, it's funny because every time we release new products, the bunch of us are always at the message boards like, okay, what are they going to say? What's the responses? And you always get the usual gamut of we hate you, you suck, to, oh my God, that's the best feature ever. We prefer that last one, but we'll accept. But this year we did something different in that Autodesk as a whole, not just media entertainment, but Autodesk as a whole was going through a major rebrand, and you're seeing some of the results of the rebrand happening now. And funnily enough, I think the biggest reaction across the entire internet was about our rebrand. It wasn't so much, everyone's like, hey, the software, cool, yeah, but what the hell with the rebrand? What's going on? So I want to set a few rumors to rest. There was one email thread or discussion board thread we thought was hilarious when someone said, oh, I can't believe it. Autodesk just went and spent $1 billion rebranding. It's like, yes, we spent $1 billion to make this. Just want to let that set in how ridiculous that sounds. Basically, we have an internal team that actually spent a number of months painstakingly building and designing what you're seeing here, which is this particular one here is the hero image, which comes up on the splash screen for Maya. If I flick through one more, here is the hero image that comes up on the splash screen for Max. And then last but not least, the hero image that pops up when you load Softimage, for instance. The one thing I just wanted to point out about these, because a lot of people don't realize everyone's like, what the hell are those? I know you're all thinking it. What? Because I said the same thing when I first saw it. When they were designing all the look for all of Autodesk, every industry they had to think, what is the quintessential thing about media and entertainment? What's the quintessential thing about manufacturing, architect, all these other divisions in the company? And we came down to one of the quintessential things about media and entertainment. What is the vast majority of what we do involve? It's motion. So what you're actually seeing in all these shots is a motion of something. We're not going to tell you what it is. You can try and figure it out. But each one of these actually represents either a motion capture file that we pulled out or an animal moving in some way. And over time, we'll probably let it trickle out exactly what each of these things are, but we like to leave people a little guessing, at least for a little while. But each one of these things actually does represent some sort of motion. It's actually been pulled through time to create these things. So just to give you an idea of what it is you're looking at every time you launch your product and see a splash screen. So, sum up, motion, not $1 billion. Although the 4 guys that worked on the hero images would have been happy to take it. Okay, so moving right along, we're going to jump on to the first portion of this presentation. So I'd like to introduce Daniel Berkovic, and I'm hoping I got somewhere close on your last name. I always get a little disturbed when it's like 3 or 4 consonants in a row. It always gets me a little worried. Who is one of the people who worked on the short NATALIS. They won a award at the VES Society for Best Student Project, I think it was. What's the name of the word? Yes, Student Project. So at this point, what I want to do is I want to hand off to Dan, who's going to take you through some of the making of and what went into making the short. And of course, he's going to show you just a little bit of the short itself so you can get an idea. Exactly. So Daniel, take it away.
Thank you. So today I'll talk about NATALIS and the production and the design process that went behind it. And on the project, we were a core team of 5 people. Working on this for 18 months. It's a long time, but we just finished in time. And I want to start by showing a little teaser of the film. Thank you. So the development started actually for this project a little bit earlier. When we, in 2009 actually, this original idea was developed by another student and a friend of mine, Felix, when he planned to make Natalis, a film, and I joined the team very early on. And the original concept had several characters in them, several sets, and way over 100 shots. And what was even more challenging, that these characters all individually had a journey, and they were evolving through during their journey and meeting at some point. So the concept was too ambitious to be realized, and Felix pursued another project for his graduation, and I left the school for 1 year to study at VFS. And 1 year later, when I came back, it was my time to decide what will I do for my graduation, and I still liked the project. And I called Felix and asked him, what are you doing with this? What's your plans? And he said that he didn't have any, and he would be happy if I would take over the idea and could do with it whatever I wanted. So I had the idea, we'll do a trailer for it. And this was the time when I pitched the project to other students at university, and other team members joined, also Marcel, and we together directed the film. We started developing the trailer, and although the film would be, or the trailer would be a lot shorter. We'd still have to develop all the assets. So throughout the process, we realized this is still too complex just to do justice to the original concept. So we sat down and thought, what interests us most about the story? And it became very clear. The two main characters you saw in the teaser, Ea, the robot, and Enki, our monster, had the most interesting relationship, the most interesting background. So what we did, we took these two characters out of the story and created our own little piece out of this. And so eventually, during this process, it became a short film again. In the whole process, as you can imagine, because we had so many stages, we did hundreds and hundreds of storyboard images. And as soon as we narrowed it down and found out what we wanted to do, focusing on these two characters, we took these storyboards a little bit further, took mood sketches, because we didn't have any dialogue in the film. It was really important that visually it became very clear what we wanted to tell. And this was the basis then for our first animatic. For our project, we also decided to use motion capture. That was very clear early on. And so we went very quickly in the previous stage, because out of an animatic, you can't really plan a mocap shoot. You have to see where in 3D space are the characters, how are they moving. And as you can see in the top left corner, we started out really rough. And during the process, we discovered the new viewport features of Maya. And so these really rough previous scenes became gradually evolved with the project and became more detailed until we updated them with the latest assets, the latest textures and shaders. And as you can see in the top right, what we had in the viewport was actually not that far away from our final shot. It was really helpful for our process. And during our whole design process, we did a lot of concepts. And this image here is, I think, the most important one, because when we were redeveloping our film, I sat down and did a few sketches, and this one came up. And that was the point for us when we thought, okay, this could actually work. This is a film we want to make. And although the film looks different now, I think the essence of the film, what this image shows, is really is still in there. Another visual concept for us was contrast. We wanted to focus on contrast because we have our monster but organic creature representing this wasteland, and then we have our synthetic creature, the robot, representing the forest, the life. And we wanted to present this visually. So what we decided to do is, for the desert, just exclusively use a very warm color palette and bright colors. And then for the forest, rather choose a darker and more cold color palette. This was then a first concept for our robot. Again, very desaturated and rather cold color palette. Only the eyes were the only things that we made a little bit warmer. Here are a few concepts from an earlier stage where we still had this journey aspect of the story in there, but that eventually got removed. And this image here, when we were developing the visual look of the film, I started out painting the robot and the plant, and then it was about to what could be the design of the forest. And it became very clear that it shouldn't be too fantastic, because the visual focus absolutely had to be the plant. The most interesting thing in this forest had to be this plant. So we decided to go for a more, I think, natural look as a forest, as a viewer, as you would expect it. And this was a last concept for the visual design for the creature in the desert, as well as the color palette for the desert. In terms of character design, we had a great base to work with, because as in 2009, the original concept was developed by Felix, and you can see these pencil drawings, really fantastic reference. That was the base we were able to work with. And due to the process that we changed the story, and one of the main characters, very important side character of the original story, became our main character. This also affected the design, because as you can see in some of these designs, they're really great, but they're not very natural. So we wanted to make our main character more humanoid so the viewer could identify with her. And this was also the time to test out what the look of the film will be. And this was a first test when we had our design for the face and thought this is what we're using. We made a first model, textured and shaded it. And this was the result we thought is naturalistic but not too realistic, so we could still pull it off in time. And because we had a lot of concepts already from Felix, we didn't spend a lot of time in the 2D aspects. We pretty much early on went into 3D concepting the designs. Marcel did a few other iterations just to bring it together, but then we sculpted. And it was a really fast process just to explore these original designs. For the next step, as soon as we locked down our design, we retopologized it in Max, modeled, then the hard surface modeling started to bring the character together, and a few clicks later, this was the final results. Another aspect for us, because the original concept you've seen earlier, we kind of liked it, so we just took it a little bit further in Mudbox, refined the shapes of the face, and until we had our final look, which we liked. Textured and shaded, it looked like this. And as you can see, this is not a photoreal face, but it has natural proportions, so the obvious danger is that we could end up in the process in the uncanny valley and have a really scary main character. But we were lucky because in the process when we were designing we're in pre-production for our film, we had Thibaut Weise, a professor from EPFL, University in Lausanne, Switzerland. He was presenting his face capture technology called Face Shift. It's basically a markerless 3D scan that captures the performance of an actress or an actor and translates this to a predefined 3D mesh, in our case, the face of our robot. And the limitation, what it has is the eyes. It won't capture the eye performance. So what our rigger Tom did, he built an iRig setup completely with Maya muscle, so we didn't have to do any blend shapes. That was really working really well. And here a little test of what we received from our capture sets. Because in our film, there's no dialogue, so all the emotions have to come across with really subtle movements, and this was a great base to work with. We used this and built an animation rig on top. However, there were only a couple of lens shapes we actually created because most of the performance we were able to get through the 3D scans. But in some cases, the timing wasn't working or we just wanted something else, then we had our rig on top. And our other main character, this is a visual feed or representation of our creature from our teacher. Although I liked the design, we went for a different approach. These were the first images or concepts that we made for it. And the second image, we liked the design, so I took this and started building a maquette. And I didn't finish it, but I took it far enough to show the design how it should look like. And what we did after that, or as you can see in the maquette, it's working in this pose, but the anatomy is kind of not working. So it's probably working in this pose, but we started doing research. And research looked like this. We were watching videos, hours of videos, and bought ourselves magazines and anatomy books. And as you can imagine, this resulted in a lot of mobbing from teachers as well as students. But we endured it, and I think because we wanted to make sure it's really just working properly. And this is the result of all this research, the final sculpt of the creature. So what we were focusing on is have authentic anatomy. So once he's moving, it would not fall apart. And obviously his face, we had our own design touches on them. the whole sculpting and texturing process was all done in Mudbox. So it was nice to have it within one software. And as you can see in the turntable, what we finally rendered and what we've had in Mudbox was really close. So that was a nice process for us. For our deformation, we tried something new for us. We had a skin mesh, which you can see here. It's if you move your arm or your body, the skin slides on top of the muscle. So we created this mesh and had a muscle mesh underneath. So these two meshes combined allowed us to avoid unwanted stretching or weird deformation in especially the shoulder area. And this was driven by muscle rig. Tom went very far in creating each individual visible muscle, as well as a skeleton underneath to have the right insertion points for them. And as you can see here, we layered everything on top, which resulted in a quite nice deformation. And what was nice about this in the whole process, the rig itself was that well done that we didn't have to do any shot sculpting. So even in the shoulder area, where you usually have trouble and have to tweak stuff, it worked really well. So the research and the pain paid off. Here, a breakdown of what we shot when we did motion capture, translated the data in Motion Builder on our animation rig, tweaked it, then the deformation rig with the muscles, added obviously some effects, and the final result. And our mocap, what we mocapped for her, for the robot, worked really well, but for the main character, for him, we had to animate by hand quite a lot just because he was too big, and certain shots, things that our actor couldn't do. And what we built on top was displacement map, tension displacement map. So as you can see here, he's flexing his muscles, and we sculpted displacement maps, then had a displacement node deform this in the viewport so you could actually see what you were animating. And this also then was driving displacement, the intensity of displacement maps to get really all the detail within the shot. Another big challenge for us was the forest, technically, basically, because I had never worked on such huge sets before. And we had nailed down, in terms of look, we decided to go for not to go too crazy in terms of design. And this was the first test that we made, and we were like, ooh, okay, this is not looking very good. So we'll just try it again, and tried this. Still not what we wanted. And kept on refining and trying out different ways to enhance the scene and make the forest look good, but it didn't really work out. So but we learned a lot during the process. So we tried it again, this time working on a shot, really. And we thought, okay, this is not looking terrible. Kept on refining and adding detail, designing the plants and everything surrounding while we were modeling it. This white thing in the center is a tree I never textured. I don't know why I kept it in there for months. And then a few clicks later, we had this. And what we also did is we split up the forest into several pieces. So because the individual scenes were that heavy that we couldn't have all the forest in one scene. So we layered it. And this had some advantages in terms of we were able to have lighter sets, but as well, when we rendered something, the render times were slower, and when something went wrong or certain parts weren't working, we didn't have to re-render the whole shot, but instead just individual pieces and comp it together at the very end. Here another breakdown. This middle ground is the example I was showing earlier. and the final result. So that sums it up. I'd like to thank the whole team who were contributed to putting together the things you've just seen today, and like to thank you for your attention. Thanks for having me. And if there's any questions you would have regarding the presentation, I'd be happy to answer any questions if I can. Thank you.
Thanks a lot, Daniel. Now, I just want to point out that a lot of times when we do these events, we'll have, you know, someone from the big shops, Ubisoft come out. We'll have someone from SPI or something like that. And at this event, I really wanted us to show what can be done with our tools by students, people who don't have a massive infrastructure behind them, people who are really you know, doing this just for the love of doing this stuff at this point. And I think it's really impressive what can be done by a small group of people over, I mean, admittedly a fairly substantial amount of time, but just awesome work. And it really speaks volumes to how far technology, hardware, processing power, everything has come, that you can have some students working at a school building shots and pieces like this. And obviously speaks an awful lot to the talent base that's coming up right now. I always said, I want to make sure I'm like a producer or a director or something by the time the next generation gets to me, because there's no way I'm competing. So now we're going to dive into the portion of the presentation that I'm sure everyone is waiting to see a little bit of, which is some of the new features in our products. What I wanted to start off with is just a quick talk about small annoying things. How many people are familiar with this concept? About a third of you. So I'm just going to quickly run over this. About 2 years ago for 3ds Max, we started a website called Small Annoying Things. And the idea was, if there's anything in the product that you just find annoying, that slows you down, that causes problems, but it's essentially not a big deal. It's not like give me an entire new modeling system. It's more like, I hate that I have to always click on this to make this happen. We put a forum up where you could suggest it. And then everyone else in the community could vote on that suggestion. So literally there are hundreds of suggestions in there, but a few float to the top every year. There's always like, oh, here's the top 20. And the beauty of this was our programming team always has moments of downtime when the thing they just finished has gone off for testing and they're kind of in a lull as they're waiting to or doing some research. And they've got 6 hours one day. Well, they can go cruising through the site and go, oh, I know a lot about the code around that. Let me go and take a look at that. And sometimes in just a few hours, they can fix what's been driving you nuts for 5 years. So that's why we built this site. And then this year, it was adopted by the Mudbox team as well as the Maya team. And so in this 1 year for this release, we finished 33 small annoying things for Maya, which is a huge number of... If you add up the actual time saved based on all the little fixes in these small annoying things, it makes a huge difference. We added 10 for Mudbox and an additional 11 for 3ds Max. Again, they're huge. I absolutely encourage you to check out the site, and if you have things that annoy you and you're playing with the newest versions, you're like, oh, it's still here, post in there. And also, go in and vote on other people's stuff, because the more votes happen for these things, those are the ones that get fixed. So absolutely go and do it. Our dev teams have the time in these little time slices to do it. Please do so. It really makes a difference. But with that, we're now going to get to the kind of the meat and potatoes of this. We have about 45 minutes to show you a bunch of new stuff in all of our products. Not nearly enough time to show everything, so my guys are going to show you bits and pieces of highlights, things like that, stuff that they consider kind of the cool, useful, interesting, basically the stuff that makes them happy. And anything else that isn't in here, by all means, feel free to ask us after when we're all drinking and eating and enjoying yourselves. You can ask about any other features. And as well, all of the feature information is up online. We have a number of other videos that cover other things. We also have a new feature document that will go through details of a lot of the changes, things like that. So with this, I'm going to pass it over to Chris Murray, who's going to start off by taking us through some of the cool new stuff in 3ds Max.
Great. Thanks, Sean. There's 4 of us for 45 minutes? I thought I had the whole 45 minutes.
You're going to have to compress.
Highlights?
You're going to have to compress.
All right.
And I have the hook ready.
I know. Thanks. Thank you, everyone. Thanks for coming out. Beer and food? Yeah? All right. So again, my name is Chris Murray, and I'm the 3ds Max technical marketing specialist. That means I just get to play around and have a lot of fun. So I am aware of my time. I don't have a whole lot of time to show you what I would like to show you, so I'm going to just try and get through as much as I can. There's a lot more new things than I have time to show, so I've picked out some of the things that I've enjoyed working with throughout the beta cycle and the development cycle, and things that are fun for me. So hopefully that will come across, and we won't get into everything, but we'll get as far as we can. So first I want to start off just by reiterating our Max viewports. We've had some DirectX 11 improvements behind that, some of the under-the-hood type things. Our Nitrous viewports continue to improve. I want to thank our friends at Mixamo for creating this content for us. So I always like showing good places, nice images to start, so I just wanted to be sure that we showed that. So I'm going to go ahead and jump into probably my favorite new feature in 3ds Max 2014, and that's the Perspective Match tool. It is one of the reasons I like it so much is that it is so easy to use. So when you're working in scenes and you want to do 3D registration with a 2D backplate, it's sometimes challenging to get the cameras all matched up and get it to be doing what you want it to do. And let me grab that and pop it open there. All right, we'll just... There we go. So I've brought in this image in here, and I want to, before I start doing perspective match, I just want to make sure everything is configured very quickly. Now you'll notice I started that from scratch. I just dragged an image right into the viewport and said OK. So that's kind of important because I want to make sure that we're actually doing it from scratch so you can see how it works. So I've matched our view there. I don't have a camera. I don't have anything else in the scene yet. And I'm going to go to activate the perspective match tool. And all we do is show vanishing lines. And very quickly, the tool is ready to go. It's just, that's it. It's like 3 sets of lines, 2 each. You can choose whichever axis you want to do. We're just going to go ahead and do 2 axes to keep it simple. And the way it works is you see our grid on top of our image there. I'm just going to choose a matching set of parallel lines, and I'm just going to start positioning them. And they just have to go off into vanishing points. So I'm just dragging the lines, and you can see the grid is moving around as I do that. And I'm just making sure that I'm choosing straight lines that are in my image. So I'll drop that in there. And you can see as I move my perspective lines, the grid begins to take place, and all of a sudden, very quickly, I have something that's usable. Now, another new thing that I really like that will help me tweak this a little bit is my 2D pan and zoom mode. So what I've done is I've activated 2D pan and zoom, and previously you couldn't actually do what I'm about to do. I don't have a camera in the scene yet, but if I had a camera, it would work the exact same way. I can actually pan and zoom. My keyboard shortcuts have changed because I think Daryl was on here just a minute, so let me pop into that real quick. Actually, you know what I'm going to do? Let's do that. I'm going to go ahead and get our rotate here, just old school. There we go. Okay, so you can see I'm zooming in and out, and the image registration is staying with my pan and zoom that are in there. So I can actually zoom in, and let me go ahead and get the pan tool here. So now I'm actually panning with the scene in here, and I can zoom in further and continue to refine my tools. So I can just go ahead and grab them and move them over here. And this is really beneficial because I can get a lot closer to my object, to my image, and see exactly what I'm doing. And you'll notice right here it says my pan and zoom is 565%. So when I exit pan and zoom, it's just going to pop me right back in there, and I can adjust the vertical position of my plane, and we have a pretty decent match there. So now at this point, I can just merge in a piece of geometry. I'm going to pull in part of the Statue of Liberty, and we can then adjust the distance. Now, I still haven't created a camera yet. I'm just going to rough this in because I'm really short on time already. So I'm just going to move that around, and using these tools, I can get a rough position, get a rough camera position, and then I can just create a camera from there. So I'll do Control-C, and our camera's right there. Now, obviously, I'll tweak that a little bit more and tweak it up, but it works really well. And kind of in that same spirit of our 2D pan and zoom and our perspective match, we have populate. Now, I know a lot of people have seen populate. It might not be a big surprise because it started off in Autodesk Labs and evolved from there. So I decided to play around with it a little bit and see how I could kind of use this for M&E. A lot of the approach with populate was that it was more of a design visualization tool. It is not a crowd system per se. It is not necessarily for creating a ton of people. I wanted to try and use it in more of an effects type shot, just to kind of play around. So what I've done here is I have a clip, and I've loaded some footage. We've done a quick track of this footage. It's really rough. And I want to use populate to actually add some background elements into the scene. So I'll go to my top view and pan over there, and I'm going to zoom in a little bit, and I'll go ahead and open up our graphite model, or our ribbon, I should say, and we can create flows quite this simply. So I just turn on the create command, and I'm dragging flows around, and then I'll go ahead and create some idle areas, just drag some idle areas. And the difference between a flow and an idle area, flow, people will be walking. Idle areas, people will be standing. I'll go ahead and go back to my perspective view and just kind of arc rotate around a little bit and move this around here. Okay, and when I'm ready, I can just say simulate my scene, and it's just going to go ahead and throw some people in there. And I'll just right-click. I'm going to select this and just move it down here. Now, my background hasn't quite updated yet, but that's all right. So I'll just drop down there, move it down, and resimulate. And I'll switch back to our tracked camera view. And you can see now that we have some people that are in there, and I'm going to go ahead in my viewport background and just make sure that we're matched to the rendering output for this. Okay, that's fine. Let me actually show you the final piece. So you can kind of see that we're able to quickly put some background elements in here of people that are moving. There's a lot more people in this shot. I'll go ahead and let it play through a couple times. Again, really rough. I didn't tweak the composite a whole lot. But I used populate. Obviously, the hero of the shot in this case is the Statue of Liberty. We just wanted to add some elements in there that gave us the idea that there were a lot of people around the base of the statue. So that's kind of an interesting thing that we can do with that. Let me go ahead and move on to something else here. Okay, this is great. I'm actually pretty excited about this one because this has a lot of implications for designers and motion graphics artists, and that is our new vector map type support. So we can now in 3ds Max support Illustrator files and PDF files directly as a texture map in the material editor. And actually, one more thing. This is kind of a small annoying thing I want to show you here. So I have it up here. I'm going to show you the vector map in just a minute. But this was one thing that I was really excited about. In Configure under Display Performance, we can now dial in the texture size. I'm really excited about that. I heard one person clap. I think that was outstanding. Outstanding for that, right? So I'll go ahead and say apply for that, and then our texture should clean up there. So let me go ahead and select this object. I'm going to open up our material editor so we can kind of see how this is implemented. It's a straight up vector map, a really simple image I did in Adobe Illustrator. In this case, this is a PDF file. And with the PDF file, the way it works, if you've used that a little bit, let me pop over to this one and drive down here. With PDF files or Illustrator files in general, you have a thing called an artboard. You can have multiple artboards, and you can actually animate between the artboards. So you can have, in this case with this kid here, I've used our attribute holder, and I've just designed a slider bar to animate between the various artboards on there of the vectors. So you could do, this is doing a whole face change, but you could do individual eye changes, phoneme changes, things like that. So again, and the thing is, it's a vector map. So you can zoom in and you get the resolution you expect out of a vector map. So it's really nice that you can do some resolution independent stuff. One more little experiment that I was working with vector map was I wanted to try and use it in a couple of different places in the scene. And in this case, I used it in a soccer ball. I'm going to go ahead and load some of the media up here. I just did a quick render just to see how it worked over time. So I have an animated vector map. I'm using the same vector map as the source map and as a displacement map. And since you get the resolution independence of the vector map, I thought it would be interesting to see how it reacted as a displacement. And you can see you get really clean displacement. I didn't do a whole lot of tweaking on the textures, but it's an animated displacement where the close-up of the ball, you get the deep kind of cavernly look in there, and then as the ball pulls away, it reduces the amount of displacement. So I was pretty excited to see that application, and I think there's going to be a lot of potential with the vector map support in there. So I was happy to see that. By the way, the ball image is an AI file, directly right out of Illustrator, and the kid's face was a PDF file. So some good things there. So I'm almost
2 minutes.
2 minutes. 2 minutes? My timer says 11 minutes. All right. Oh, that is 2 minutes. All right.
Good math.
Okay. So a couple last things I want to show you. Again, you know, we've now fully integrated our particle flow Mass Effects particles in here. And if you haven't seen that, there's a lot of interesting things to see. So there's a couple of files that I just want to take a quick look at. And what particle flow brings, particle flow brings to the particle systems in 3ds Max are a lot of different effects that are very simple to set up. So this effect looks like it might be a fairly complicated effect, but in actuality, when we open up the flow, it's 2 events. Okay. So, and the other thing is that since it's a Mass Effect system, it's a physics system. In this case, we're just doing a simple reveal with these particles, but we can open up some other things. Let me open up a couple of other shots here. And you can do physics-type stuff. And these are all really easy to generate, and these are all particle-driven effects. So simple to set up, simple flows, a couple of other things here. Let's see. Of course, everybody likes to blow stuff up, right? So you know, really great particle effects going on there. Again, really simple flows. And let me open up one last one. I think this one is really cool. And actually, I do want to mention one thing about this. Is so you know, this is the particle flow is made up of basically 2 different types of flows. We have a couple of special operators in there. And let me open them up and show you where they are. First of all, this is the flow for this. I got like 4 seconds. This is the flow for this. I feel the hook coming out. Down here on the bottom, you can see all. Are you going to hit me? That's cool. All down here, you can see the asterisks of the new operators that are in here. And one of the things about the P-flow system is the introduction of the data operator. And if you're not a TD, you still have the ability to create really simple flows that do great dynamic stuff. If you are a TD, you have access to subparticle information with these operators that allow you to do really complicated types of effects like this. So I can tell Sean is burning me on the side of my head with his eyeballs.
I'm actually going to give you 10 more seconds to hit X.
10 more seconds to what?
Hit X.
Hit X? Oh, my goodness. All right, so this is another new small annoying thing. When you hit X before, it hit the transform gizmo. Now with X, you hit X, and you can type in literally any command, and it will show you the list of commands that begin with that. So if I want to do a relax on this, that's great. This is a really great way to move things around. I can do render. I'm just typing in stuff. I'll say, let's see what LU, or we don't have no commands that begin with L. How about that?
Little known fact.
Right? You know, bend. Any of the commands that you want to have quick access to, it prevents a lot of mouse travel, saves you a lot of time. I know a lot of people are command line type folks, so this is going to be a great thing. And by the way, you'll notice that it pops up wherever my mouse is. So it's not like I have to hit X and then travel to it. It follows my mouse around the screen. So a lot of nice little finishing touches in 3ds Max. I'm really excited to be using it. So I want to thank you for your time. Thanks to my peeps from Concordia. Woohoo! Right? They were in our live event, our expert challenge. They're learning Maya, but I've shown them the love of 3ds Max. So
there we go.
Thanks, everyone.
Thanks a lot, Chris. All right, coming up now we have Adam Sale, who's going to take us through some of the new stuff inside of Softimage.
Hello, everybody. I guess I'm the one civilian demonstrator here. I'm from Vancouver. I work out of Capilano University and run my own studio, John Co Entertainment, small two-man studio. Sometimes ramps up a little bit more than that. So I'm here demonstrating the new features in 2014 for Softimage. First of all, I guess I'll mention that the development team moved over to Singapore. It's a brand new development team, and to be able to ramp up in such a short period of time to create some of these improvements is pretty impressive. Huge number of bug fixes for 2014, but I'm going to focus in on three main areas. First of all, Cyflex has finally got per point attributes. So for us that are dealing with cloth a lot of the time, again, this is just a low-res version of the character, we can finally use texture or weight maps to drive our cloth simulations with various attributes. So if we take a look at the ice tree for this, just let this guy simulate for a bit. This is not cached, by the way. This is just running all frames. So we've got our cloth simulation running. If I open up the ice tree for it here, you can see in the simulation region of our stack, there's two new ice nodes. Apply Cyflex Cloth, which is a 3D vector per point compound. We're simulating the Cyflex Cloth. And in this case here, we're using weight maps to drive the area that's simulated. At the same time, move this out of the way here, we're also introducing the ability to use per point attributes with the constraints, things like the pins. And if you just take a look at the character's genes where I've pinned things down, we'll just take a look at the, there's a pin map. I'll just isolate that. Okay, so that just isolates the belt. And at the same time, we've got another weight map here that's defining where the cloth should take place. So those are some pretty big improvements for Cyflex. It was a little bit limited before we had per point attributes. It also accepts dynamic attributes as well. So you can use distance to object to modulate things like stiffness, bend, shearing, etc. So that's kind of cool. One of the big improvements that I've been a real big fan of is kind of a rethink of crowd simulation. And Chris was showing you how Populate worked. It wasn't really designed as a crowd simulator. Well, this is here. And I'm just going to use the default character to take you through a basic workflow and how it's changed from 2013. So I'm in the ice menu, and actually I'll just close down this ice tree I have right here. And we're going to start off by simulating a new pedestrian crowd. So this is just a quick jumper we have to get yourself started. There is a pedestrian character that's given to you by default if you wanted to use that and play around with it. Otherwise, you can import your own characters. It's important to note that any type of character can be used in crowd. It could be a car, it could be a quadruped, it could have 50 legs. All that matters is that it's got a COG, the typical cog that you use as the pivot of your character around the pelvis, and it has to move forward in 3D space. So I'll import a default pedestrian. So this is just importing a model here. It's not a great character, but you'll get the idea with it. And it suggests that we use an idle source. So I've got a standing idle pose, a walk, and a run. And I could get additional actors. In some of the scenes I've been working on for the new features, I had 10 actors, all textured. It's just a little bit slow for demonstration purposes. So we're creating the pedestrian crowd. We're pulling in a walk, a run, and an idle cycle. And it's going to go and set up our initial crowd. So there's our crowd right there. Let's add a few more characters. I'll just take the emitter, make it a little bit larger. You can see the crowd just kind of redistributes in there. Let's go into the simulation region and inspect the crowd simulation tree. So for a lot of people that are new to ice, dealing with one ice tree can kind of get a little bit overwhelming, and crowd uses 4 ice trees, but as soon as you get used to the workflow, it's actually pretty intuitive. First of all, if we look at our animation sources that we've brought in, these are just actions that are sitting on our models. Here's the idle, the walk, and the run. And then those are fed into the emit graph, where we are emitting characters from our geometry. Let's just put a few more characters in there. 400. Okay, boop, there we go. There's our 400 characters. So you can see that, for 400 characters walking, it actually simulates pretty quickly. And they're all offset in time, which is kind of cool. Let's take that back to the first frame here. And let's close that. And what I also want to do is take a look at the new animation, blending, and behavior portions to the graph. So let's say I wanted to bring in additional animations. How would I go about doing that? You can see the animations that we've brought in are already defined here in our animation blending tree. We've defined in idle animation state. So we're basically taking the actions from our models and defining states in which those actions perform. So we have an idle state. We have a moving animation state, which takes advantage of the character velocity. It's basically particle velocity. And we animate these from slowest to fastest, from a walk to a run. And the coolest thing about this is the state transition. So any animations you bring in, whether keyframe or motion capture, you just define transitions between your idle state and your move state, or whatever states you bring in. It automatically handles those transitions. And these are bidirectional transitions, so from idle to move, from move back to idle. But let's go and add a couple more actions in here to make it a bit more interesting. We'll get these guys to collapse. So I'm going to go to the Actors menu, and I'm going to inspect my actor proxies. As you bring in your model, it's converted into a proxy. So I'll look at the pedestrian mesh proxy, inspect the animations. So all the predefined animations we have on that character are available to us. And let's give him a bit more variety in his movement state. So let's get a walk slowly, a jogging cycle, and we'll move those over into our selected actions, and we'll use them. So these three are already in use. And you can see that they are using a COG for forward progression. So we'll select those, and it'll apply it to the original actor. You can kind of see him here in the middle of our crowd. Okay, so it's bringing those guys in. And let's also have this character, let's have these characters collapse as well. So let's collapse the character. We'll move that over as well. Okay, so there's our collapse. This is an on-the-spot or an idle state, so we don't want to use COG. We'll select that, and that'll get added into our ice tree as well. So if we wanted to add this to the tree, we'll go into the simulation menu, inspect the crowd simulation tree, and you'll notice back in our animation sources, if I edit that, you can see that it's now added in our slow walk, our jog, and our collapse. And we're going to utilize those in our animation blending tree. To do that, I'm going to expand and open that. I'll go full screen here. And for the idle state, that would be the collapse state. I'll just copy and paste this one. And I'm going to give this a new state name. So I'm using the pedestrian mesh to do this, and we'll call this the die state.
Because you can't have a crowd sim without a die state.
No, you got to have that, right? So that die state is going to use the collapse action. And so we'll just plug that in. I just need to make room here in my execute port. Just insert a port after, plug that guy in. And as far as our move state goes, if I double-click on that, you can see it's only taking advantage of our walk and our run. So we need to make room for the slow walk and the jog. So I'm just going to right-click and add in a couple more reference. This takes advantage of string data, by the way. And what I can do now is organize these from slowest to fastest. So we'll go from a slow walk, to a jog, to a run. Now we need to blend these all together. And that's what's happening down here in the state transition. We already have our idle state to our move state. Again, it's bidirectional. But we also want to be able to blend from our idle state to our collapsing state, or from our moving state to our collapsing state. So I'll pipe that guy in, double-click on my state transition. We only want this to be one directional. If my character collapses, I don't want him getting up again, unless he's Rocky. And these guys, they're definitely not. So we're going to go from a move state to a die state. And we'll do this again, copy paste, and we'll set up the transition from our idle state to our collapse state. So single direction, idle to die. So that's all done. I should also mention that we can also set up pose modifiers. So creating a bit more variety in your animations is pretty easy. To offset head motions, offset arm motions, things like that. Let's move right into the behavior tree, though, because this is where the real meat and potatoes have been changed. So this is the behavior core that's been added, and there's 3 sections to the behavior core. One is the simulation region, and this is really just using a velocity graph on the characters. So we're basically just blending from different velocities using target speeds here. Our post-simulation region to the graph is really for dealing with, interacting with grounds, avoiding obstacles and walls, things like that. And finally, down here in the animation state section, we're choosing which states to use when we pull them in. So let's just set up a couple of examples here on this. So you can see here in my states, I don't really have 2 minutes. That quick. Okay, well, let's first of all,
your voice now, please.
Yeah, let's vary this up a bit. And there we go. We'll randomize some of our animations here. So I'll go and do a randomized value by range on that. We'll give our characters a random speed between, let's say, 8 units and 40 units per second. If we take a look at what that's done to our crowds, hit play. So now what we're going to have is we're going to have some characters. Let's give it more frames, 500. So some of the characters are running now. Some of the characters are slowing down. They're all avoiding one another. So that's pretty useful. Let's see if I can get a death in here before I am kicked off stage.
The beauty of both dynamics, physics, and crowds is torturing the characters.
Yeah, I love doing that. So what I'm going to do is use a null, and I'm going to use a set of rings, and any character that comes within this is going to die. I don't know if I'm going to have time to set this up.
The
so we'll
vortex
call this
of death.
This is a die null. And I know I'm not going to have enough time to do this, but let's just make this happen.
I'll give you a few extra seconds to make them all die.
I don't know if I'll be able to do this, but we'll go with an initialize. So we'll initialize some crowd attributes. We'll do that on our emit graph. For this, what we want to do is set up a Boolean function to determine whether or not our actor is actually dead. And you can see in the initialization graph here, is our actor dead? No, it's not. Okay, so we've got that. The next thing I want to do back in the behavior graph here is I want to be able to set my animation states determining whether or not they are dead. So let's just do a quick test inside of a null. So I'm going to do a test inside of the null. I need to pull that null into my graph. I'll use the little handy F3 button to bring my object in. I'll provide that as my null name. And we also want to tell, I'll run a condition on this. So I'll run a conditional loop if our character is inside of the null, or let's just do a get data. We'll pull in a reference to ourself. We'll explore for that. We're going to pull in is our actor dead? And let's just choose whether or not he's inside of the null or whether or not he's actually dead. So we'll just use an or for that. We'll plug that guy in.
How fast can you wire?
If I had my stylus, I'd be a lot quicker. So we'll plug that in there. So if our actor is dead, then what we want to do is we want to set our animation state to the die state. So we'll copy paste this guy here. We'll set that as true. And let's go and copy our state selector, copy paste. How am I for time?
Over.
Oh,
I'm giving you a little bit more.
Fair enough.
I'm feeling for you here. I'm giving you time.
Yeah, I don't think I will.
And don't worry, Craig. I won't take it away from you.
Yeah. All right, so if these two statements are true, then we run our death state. Otherwise, if they're false, we're going to run this state here, which blends between our move and our idle states. Let's pipe that guy in there. And we also need to blend our velocity off as well. So we'll run another condition on that. So this is using all the vanilla nodes of ICE. So a lot of the stuff that most people are familiar with could be taken advantage of here. And let's see. So if we're testing inside of the null, the actor is dead, then what we want to do is set that to false. And if it's true, let's go and set some velocities. Let's go here to crowds. Let's go to, let me look up velocity. Set velocity by speed and direction. And we'll drive that as true. So if we're inside the null or our actor is dead, let's set the velocity of the characters to 0. And so I've got that there. And I'll also run another condition here. So we'll go with an if.
How many more boxes we got?
Just a few. If you can give me 3 minutes, I will be good here.
I don't know if I got 3 minutes. That's
2?
2?
1.5?
Okay.
We'll go with 1.5.
1.5, maybe?
All right. So we'll say here, if we're inside of the null or our actor is dead, then what we want to do is set our velocities to 0.
I love these statements. If we're in the null or the actor is dead.
Yeah. So we'll set that to 0. Otherwise, if the character is not dead or it's not inside the null, we'll keep this random speed here. And I know I'm missing something in here.
What haven't you done?
What haven't I done? Well, let's see what happens.
That's always my best bet.
I know what I've missed.
Oh, you remember.
Yeah. So let's go and run an execute. If our character is dead, then we actually need to set our is dead flag to true.
Ironically, it's an execute function.
Ironically.
I like when our programmers have the right jokes in mind.
Kind of sinister names there, aren't it?
Yes. Execute.
Let's go and do a set data on that. So if our character uses this death state, die, then we will execute set data. Let's go and use self. So we're referring to the particles themselves because on those particles we actually have our actor is dead. And we're going to set that to a Boolean function. And we'll set that to true. So if you've never seen ICE at work before, it's pretty cool just the way you can iterate through a lot of these tests. And let's see, am I missing anything?
About to find out.
We're about to find out. If not, I've done a lot of the new features for 2014. You can check out those videos, and they stop, and they should die. Oh, there they go.
There they go.
And
I was going to be very disappointed if we didn't have to pay off after
yeah,
that.
let's kill the rest of these guys
Yeah,
here.
oh, yeah.
Mess.
Now it's like the Independence Day's ray of doom. It's like, I love that. Perfect. Thanks a lot, Adam.
Thank
Excellent
you very
job.
much.
Extra applause for Adam. This is the first time I think he's ever actually done one of these demos for us. So I'd just like to thank him again for coming out. Much appreciated. Happy you could be here. And we got the payoff. That was all. That was what I wanted. All right. Now we're going to go on to our next presentation. We have Daryl Obert here from my team who's going to be taking us through some of the Maya side of things. So Daryl, take it away. And don't worry, I'm not going to dock you time. You can.
Yeah, I was a little concerned about that. I only have 13 minutes between me and my first beer, so I'm going to go quick. You don't have to dock my time. Don't worry about me. So we're actually going to be looking at both Motion Builder and Maya. Motion Builder's had some really great improvements made to it, and what we're going to be looking at this evening is going to be the improvements that have been made to the HIK solver. It has had a lot of bug fixes, over 50 bug fixes done to it, and a lot of it's been kind of reworked. So it's got some enhancements like the ability to squash and stretch on the spine, as well as some great improvements that were made to the double solve. So if you have like a cyclic loop where you sort of are driving a character through itself with a loop, the double solve now evaluates on a frame-by-frame basis. So it's much more stable than it was before, and it also allows you to do things like have the double solve state kind of get animated on and off, and it works properly as opposed to the previous solver that we had. So what we're going to do is we're going to look at a quick example of how that double solve can be used to basically have this character pick up the truck. So what happens is we're going to have our character come in here, and essentially there's a constraint that's animated on this hand that parents it into that truck. So his hand is now basically driving that truck around. If we begin moving that, let's move this hand over here. You can see that the truck's parented into the hand. That's a constraint that's animated on and off at a given frame. And what we want to do is we want to have this other hand also get parented into that truck. So this is what creates the loop. The one hand that's driving the truck ultimately is going to end up driving the other hand because it's going to get parented in there. And this is sort of that double solve situation that we were talking about. So to set this up, we're just going to add a constraint onto that second hand. And this is very easy to do inside of Motion Builder. We'll just go to our constraints, and we'll switch this over to a list here, and we'll go and grab parent-child. We'll set this as our source object, and then we'll grab the hand that we want to have constrained to that source object, which in this example is going to be that hand right there, and we'll just drag and drop that guy down into our constrained object, and we'll just hit the snap. So by hitting snap, it basically activates the constraint at its current position. We'll lock that so that that hand doesn't move. And what we'll do is we'll begin moving this around. Now remember, when we're working with HIK, there's always this sort of notion of, are you trying to match the FK or the joint angles, or are you trying to match the end position of a given marker or the IK? By default, it's going to try to match FK. If you start to increase the the blends for translation, it's going to try to reach the IK chain. So if we grab this hand right here and we begin moving this around, notice that other arm isn't going along for the ride. That's because, again, by default, it's trying to match FK. So what we're going to do is we're going to go ahead and turn up the match translation on this. You'll see that hand starts to transition into that guy. We'll match the orientation of it also, and we'll add a little bit of pull. Well, actually, we'll leave the pull off first, and we'll move this around. So this is the old solver, and you can see that that hand's not really going along for the ride. If we introduce a little bit of pull so that it can introduce the human IK solver that allows it to extend past that body part, this is where the problems start to come in here. We start to introduce that pull, and he just starts going all haywire, right? That's not what we want to have happen. And that's because the old solver isn't as robust as the new solver. So if we jump over to our character node and we switch from the original Motion Builder solver over to the 2014 solver, and we just go ahead and increase the pull on that guy and just kind of update this a little bit here, move forward in time, and we grab this hand and we start moving it around. Let's grab this hand right here. You'll see that the solve now does exactly what you'd expect. It's very, very stalled, very predictable. So that loop of the hand basically driving the other rig through the other hand now works properly. So this is a really big improvement. One of the things that was added to the 2014 solver was the ability to deal with squash and stretch on the spine. So this is great when you're doing retargeting. The spine on the human actually has a good bit of squash and stretch to it. So the ability for us to simulate that now in our solver, both in the retargeting process as well as when we're dealing with optical data, is really important. So let's go ahead and look at that really quickly. If we were to grab this character, and what I'm going to do is I'm just going to sort of move this guy around here. You can see as I start to move that around, that character's spine obviously isn't stretching. He starts to pull up through his legs there. And what I want to do is I want to introduce a little bit of squash and stretch into this character using some of these new 2014 attributes. So any attribute that's new in 2014 is actually color-coded for us. And you can see here that we have the ability to squash and stretch. So it's set to 90% and 110. So basically it can go a little bit smaller and a little bit bigger. And we'll just increase the stretch on both the neck and the spine. So now as I grab this character and I start moving him around, you can see that we start to get a little bit of stretch in that, and we'll over-exaggerate this a little bit so it's a little easier to see. We'll add the ability for it to really stretch that spine. We'll kind of crank these guys up. So he's going to get really long here. It's going to look a little weird, but it'll really illustrate the effect of this new squash and stretch. So he compresses down, and instead of the feet pulling off the ground, you can see that that spine is now stretchy. Wow. So again, this is really, really important when we're dealing with retargeting issues. You know, the ability for that spine to soak up errors that would happen and stop the legs from snapping or popping. It's a great new feature. And those are the two new things that we wanted to show, the two new things we wanted to show in the 2014 solver inside of Motion Builder. So we'll jump over to Maya now and talk about one new feature in Maya. And Maya's had a lot of great new features out of 2014. One of them is the scene assembly tool. So this has been a multi-release effort inside of Maya. We started it a little while ago. And really what scene assembly is it's about managing large data. It's something that's really important to, obviously, our high-end film clients, but it's really, you know, everyone's got to push bigger data around. So broadcasters are pushing big data around. Gamers are pushing big data around. So these... Exactly. I mean, these tools are going to benefit absolutely everyone in the industry. And the way it works is basically scene assembly allows you to have multiple representations of your objects. So you can have very low-res representations, things like bounding boxes or maybe Olympic caches, and very high-fidelity representations of your characters, maybe your final animated rigs and things like that. So it's kind of a two-part process. You set up a scene assembly. You define it by basically saying these are the representations of this object that I want to have. And then you have the ability to bring that in through a reference node, essentially, an assembly reference node. So I'm going to walk you through the process of setting up a scene assembly and then show you the workflow of adding those into a scene through the reference node, the assembly reference node. So let's go ahead and bring up the outliner. And the first thing that we're going to do is we're going to create a new assembly definition. So this is where we're going to basically define, you know, all our levels of detail on our object. So when we create this assembly definition, and we bring up the attribute editor, what we want to do is we want to start importing in different types of assets. So I'm going to say add a scene representation. And what we're going to do for this example is we're going to go ahead and just add in the highest res piece of geometry. So this is essentially the finished representation of this asset. We'll go ahead and we'll shade this up. So this would be our render state. So what we'll do is we'll just come down here and we're going to put a label on this called render. Now, if you're smart with your labels and you use the same labeling system in all of your assemblies, it allows you to basically do group selections and switch the states really, really quickly. Or if you want to script the state switches, you can do that very, very quickly. So that's going to be our render state. We're going to go ahead and we're going to create another representation of this. So what I'm going to do is I'm going to take this scene assembly and I'm going to export this out as a GPU cache. So there's two different flavors of Olympic caching inside of Maya. The basic Olympic cache would be, you know, your geometry that gets evaluated by the dependency graph, so you can put shaders and things like that on top of it. So maybe once you've finished animating a character with a muscle system, before you go to render, you might make an Olympic cache for it. The GPU cache is a slightly different version of that, and what that does is it basically bypasses all of the evaluation inside of Maya, and it dumps it directly onto the video card. So it's cache, direct to video card. They load lightning fast. They move extremely quick. But they don't have the ability to have shaders and things like that assigned to them because we're literally just bypassing Maya and we're dumping it right to the video card. So for big data, it's an awesome thing. If you're trying to visualize what's going on with your scene, it's a great thing. So what we're going to do is we're going to create this state. We're going to export the selected objects, and we'll just call it, I don't know, we're doing demos, so we'll call it fun. So now that we've done that, what we're going to do is we're going to add a cached representation. We'll go in here and we'll grab this fun ABC. You can see it's a very small file. As soon as we bring that in, again, obviously, there's no shaders on there, right? If you had material color other than gray, the material colors will come in. That's going to play back lightning fast. And if you had a huge scene that was millions and millions of polygons, again, it just loads instantly. Boom, it's in. It's super duper fast. So we're going to call this one GPU. So the label on this guy, we'll call it GPU. So we've got another representation. So now we've got our render representation that we can switch to. And then we've got our GPU cached representation. We're going to bring in one last representation, which is just going to be a simple bounding box representation. So I'm going to go ahead and grab all these pieces of geometry and create the bounding box for them. We're going to go up and say create actually modify, convert. Geometry to bounding box. We'll bring up the options for this. So we're going to make one bounding box for each shape. We now have the ability to also bake out animation, which we'll see in just a second on the animated character version. But for this, there's no animation on there, so we'll leave that guy off. And we'll say, keep originals. That's a great idea. We'll create those bounding boxes. So there they are. You can see that they've sort of done a good job of finding the volume of those objects. We're just going to export these guys out as my name, just because it's easy that way. We can delete those guys, right? We don't need those bounding boxes now because we don't really want them in this scene. We want them brought in as another representation, another level of detail on this assembly node. So again, we'll say add scene representation. And if we do date modified, we'll grab that guy. We'll open that one up. We'll give this a label of cube. So now we've got our cube. So we'll just kind of switch the order of these guys around. We'll put the render one down here. We'll put the cube one up. So we can now really quickly jump. We have cube. We have a slightly higher fidelity representation. Again, extremely fast using that GPU cache. And then we have our final level of detail in our assembly, which is going to be our render file. So we'll call this assembly definition something meaningful like DTO. We can save this out now. So all we're really doing is, these are basically all referenced in through this assembly node. So this file is going to be really tiny that we're going to save out. So we'll say save scene as, and we'll just call it, I don't know, cars demo. All right, so now we've got that done. Let's go ahead and close this version of Maya down. And we can obviously close down this. We don't really need that. So this is another scene, and you can see that I've got all these different assembly nodes already referenced in. So the process of adding a referenced assembly node in is just say assembly node, create reference. We'll go in here, we'll grab the cars DTO, we'll open that one up. And if we right mouse click on top of that, inside of that scene assembly, we can switch that over to cubes. You can see they just popped in. And this is where I said if you're smart with your naming, you can do blank group selections and say, you know what, I want to change these scene assemblies all over to the GPU version. And just like that, boom, they load up instantly. If I wanted to go to any one of these and say load up the render version, again, I can just basically go in there and say scene assembly, render. It's going to load in the rendered version of that piece of geometry. So very, very fast, very easy to work with. So the next thing that we want to do is bring in a character. So assemblies now work really nicely with characters also. So we're going to go ahead and import in another assembly. Let's go ahead and create this reference, and we'll grab this monster. So in comes the monster. He comes in just set up basically with a locator. We can switch between, again, sort of the same idea here, except I added an anim layer to this character. So if we go to the anim layer, he's going to take a second to load in. And basically what this is just a simplified version of the character that's got an HIK rig on it. And what we want to do is we want to do some basic animation or do some parenting operations on this. So we can now take assemblies and make relationships to other assemblies using either parents or constraints. One thing that's worth mentioning is notice his eyes. Like I've already got this character's eyes constrained into the camera at this level of representation. When I switch over to my render level of representation, that constraint's going to carry forward. Just like the parent operation that we're going to do right here with this piece of geometry. So I'm going to move this piece of geometry basically over to my character's hand here. Let's just kind of snap that in. We'll maybe rotate this guy around. And what we can do is we can then just drag and drop that. Let's go ahead and select these joints. We'll parent that in there. So now if I move this arm around, that object's basically in the mix here. So I mentioned previously the fact that the bounding boxes can be animated. I've actually got a representation of this guy that was done with the bounding boxes. So let's go ahead and, actually we'll just jump over to the full rendered version of this guy because we just did that parenting operation on there. So we'll, again, just jump over to our scene assembly. We can, let's grab it at the top level here, deselect everything. And we can jump over to the render version of this guy. So it's going to go through, figure everything out. Notice that I'm running in DirectX 11 here. The DX11 implementation into Maya is really super solid. It's my favorite new feature inside of 2014 is the Autodesk DX11 Uber shader. It's kind of being max. It's kind of moving its way around Autodesk. It's a very, very cool DX11 shader, and that's what we're basically using to view this character here. So obviously we switched out from that basic sort of bubbly guy over to the full rigged character. So if we start to play through our time slider here, you can see here comes my character. Obviously, that parenting operation carries across, as you would expect on that reference, and also that constraint that we have set up on that character's eyes. So if we wanted to finish this off by getting a faster representation of this character, I could obviously, again, just use this reference node. So if I wanted to go maybe see the cube version, so this is going to show that animated cube. The cool thing about the cube animation, when you bake this out with cube animation, is it's not doing vertex animation. It's actually setting translation, rotation, and scale keys on those cubes to make them find the volume of that character. So it's, again, something that plays back very, very fast. And if you wanted to, you could even take these cubes and make those cubes into a GPU cache. So the idea behind this is you can get ridiculously fast playback and really, really fast load scenes. Because a lot of times when you're working, you might just need to open up a scene and nudge something, right? You don't need to animate it. You don't need to make massive changes to it. You just need to make a little tweak to a set object. If everything's saved out on these caches, these GPU caches or in bounding boxes, that scene's going to open up instantly. Instead of maybe taking 30 minutes to open, if it's millions and millions and millions of polygons and thousands of nodes, if you set it all up with scene assembly, it'll open up in a couple minutes or 30 seconds. And you can then move that object, save it back out, and all the work that you've done is basically preserved and transferred over to those higher levels of detail or those higher levels of representation. So we'll finish this off by just bringing up the GPU cached version of this character. And watch the difference in load time. GPU guy, boom, instantly. If I load up the rendered version, it takes a little bit of time, right? So this is the advantage of that GPU cache to see that, what's going on with my scene. If you've got hundreds of characters running around in a crowd system, GPU cache those guys, and they're going to be really, really fast. So those are a couple of the new things inside of Maya 2014. We saw how scene assembly works, both with the definition of the assembly nodes as well as the ability to bring those in as scene assembly references. And inside of Motion Builder, we saw how we can use the new solver that's been improved in 2014 with the squash and stretch and the ability to handle these kind of cyclic loops that double solves really, really elegantly. So I'd like to thank everybody for your time, and it's time for my beer. I'm excited.
Thanks, Daryl. So coming up next, we're going to hand over to Craig Barr, who is going to take us through some stuff in Mudbox as well as a little bit more in Maya. So Craig, go ahead.
Thanks, Sean. So we're going to take a look at a modeling workflow. We'll start off in Mudbox with take a look at a couple new features here. And then we'll go into some modeling tools in Maya. So I'm probably really rushed for time. I'm looking at the clock here, Sean. I don't know how much time you're going to give me, but we'll go for it here. So I figured the best way to show the big news story here in Mudbox, the advanced retopology tools, is let's start off with something simple and organic. In this case here, we have a triangulated kind of dense triangulated mesh head here. And we have introduced in Mudbox 2014 the ability to retopologize a mesh, or for that matter, generate a whole new model in a number of different ways. So just to show that, underneath the mesh menu, you'll notice in a lot of the products here we have these things highlighted in green. This is showing you new features. So for this case here, our retopologize menu here, I'll just show the operation. By default, curves are clicked. If you don't have any curves, it's going to ignore that anyways. You can turn it off. And what this is going to do is a fully automated retopology. So in this case here, if I was to send this through for a fully automated retopology operation, it's going to give me some nice clean quads that's going to represent and hold that volume incredibly accurately. So let's take a look at how we can work with curves. And the reason why we'd want to work with curves in Mudbox retopology is to provide guided retopology. And what that is you're defining specifically the edge flow of your resulting mesh. So if I'm in the curve tools tray, I'm going to use the create curve. I'm just going to use mirroring on here. And my brush size is important. I'm going to put this down a little bit small. On this guy, he has quite a smooth surface to begin with. But if I had a creature with a lot of scales and a very kind of craggly surface on there, I might want to get really finite detail. So I would use a much smaller brush on there. We'll bring this brush size down nice and tight on this. And all I'm going to do on here is start to highlight areas where I want specific edge flow. So if we look at the wireframe with this triangulation on here, I want to work with these eyes. I want to definitely preserve some of the edge flow in there. So I'll just draw in a couple of these curves, and then we'll reveal some final or finished curves on here. We might want to preserve, things like the mouth in here as well, so we can come along. And you'll see I'm getting a little orange guide. I'm not sure if you can see that on the screen. The orange guide is giving me a directed snap. to lock that curve, and then I can right-click and close that curve up. And then what we could do is start to define where we want some of the edges along, maybe to follow, for proper deformation here on this character's head. Let's start to reveal some of these curves that I've actually drawn in here on another version or duplicate of this guy. So here I have a bunch of different curves that I just quickly drew in the same way that you saw there. And I'm just defining places that I want to have or to guide the edge flow for my retopology on this mesh here. So what will happen now is once we have our curves in, we'd go to our mesh menu. I happen to have an operation that I've already created in here. Let's use, this one here. And in here, you'll notice that the curves are changing color because I've defined how I want these curves to respond to the mesh, or how I want them to guide the retopology operation. In this case, you'll see on the menu set here, we're using these different constraints. We're defining our curves as constraints by color, the red representing hard constraints and the orange representing soft constraints. Well, what is that? Hard constraint is a definitive area, an area that I definitely want edges. So by drawing this on here, Mudbox is going to generate edge flow specifically on there. So now I could go really crazy with this and start adding a lot more curves and go as dense as you want with the curves. In this case here, just to keep it quick and fast, I can use this setup. This one here I'm using as a soft constraint, and that's essentially kind of a suggested I want the edges to flow in this way. The red I'm using as definitive edges that I'm defining in there. So we would hit retopologize. If I do that here, it's probably about 4 minutes for this mesh. Let's just jump to the retopo result right here. We have this high-res retopo. And we see the wireframe. We're getting a nice quad, clean quad mesh. The other thing to note is that those edges are following, if we zoom in here, they're following specifically where I've drawn them on there. So you can see in the nostrils, for example, around those eye lids, the mouth. And we're defining exact curves. I should point out another actually kind of cool tool with the curves here. So when creating a retopology on here, let's grab this mesh here. If I go down to my curve loop tool, I can define the way I want curves to fit across the exact, automatically across the surface for me, so it'll hug to the surface. So in this way here, I can use, let's put no mirroring on and go with an X plane. And what that'll do in this case, if I zoom in, the triangles putting on the wireframe isn't going to help me much because nothing's really uniform in there. But in this case, I can just snap click on there, and let me display those curves. And it's going to snap a curve right along the middle there. As well, I can actually do a free drawing on here of that. So if I want to define a curve across this character's neck, I can just do that to bring that in. And this is really handy because it actually will identify specific areas of the geometry that you don't you don't want to overlap. So for example, if you're working with something finite like fingers, it will identify the surface there and not cut across all of those. You can do them individually as well. So let's move forward with the retopology here. Let's show this guy here. We'll turn off the curves. And we can see just the difference in the wireframe there. So we start off with this dense triangulated mesh. And not only we haven't just reduced the mesh, we've actually retopologized the mesh to give us the edge flow that we want to work with on this. So I'm going to take this another step further here in a different version. I have another Mudbox open here, and we'll just kind of continue that modeling story here. And a different area that retopology is really useful. So in this case here, this is a vehicle, a concept for a spaceship. It's actually for our Hyperspace Madness game, if you've seen that game. This is Sven's ship that we're just kind of playing with or coming up with a concept for. All this actually is a sphere. So you see the name of the object in here is sphere. So this is just a sphere, and you can tell that the problem with working with any kind of mesh that you're pulling beyond its constraints of what the mesh topology can handle, you see that we get this very non-uniform topology. And of course, we're going to start getting stretching in these areas. You can only pull that mesh so far before it starts to degrade or crumble apart. So in previous versions of Mudbox, we'd kind of be stuck here, and we'd be able to take that mesh somewhere else and do a retopology on it, or use it as a reference to model from. In this case, we can do a lot more with that. We can actually create a new model from this. So the way that I've done this here is running what I've just shown you there with the head retopology operation, and generate this sphere retopo. And so let's take a look at that. And the cool thing about that is I actually, let's go back to the sphere for a moment here just to show that on our paint here, even on that sphere, just playing around in Mudbox as if it's a lump of clay that you're pulling and stretching, I'm also painting on it as well, right? So I'm trying to come up with the concept of these lines, the paint, the logo placement, the overall feel of this here. So this is another cool thing with our retopology solution here. When generating a new topology, I can actually turn on, if you look underneath the menu in here, we're not just doing a simple reduction. We're not just doing a simple generate a new mesh. We can guide the way we want the edges to work, but we can also transfer all that sculpted detail over. So in that case, if I have sculpted detail on this guy here, I can transfer all those layers over. So I can preserve all the sculpted history on layers on a new quad clean mesh. So I can bring over the layers. I can bring over paint layers. It'll actually create your mesh. It'll set your mesh to be PTEX, or as I called it the other day, PTEXified. I don't know if that's in Wikipedia yet, but we'll make sure it is. You can transfer over the curve information to the new mesh as well, posing, freezing, all these different pieces of data on here. So here's the resulting mesh. And that's just from a sphere, right? So we just pulled a sphere around. And then what I did, actually, before I retopoed that, is let's just display those curves on there. There's the curves that I used. So we took a look at that on the head. And here's the curves. I defined how I wanted it to cut across specific areas on my mesh so that when I provided a retopo on this, I would get my the results that I was looking for here. So what can we do with this mesh now? Well, what we can take this mesh and begin to sculpt more with it, change it completely again, provide another retopo, or we can take the modeling further. So some of the things we've done here, in Mudbox, it's quick to just grab simple little renders out of here. And in this case, when we're working with the concept, just by grabbing quick renders of the original sphere one before even retopoed, we're able to start generating some artwork with that. So just painting over top of the 3D version. And you can see we've made some changes on here, right? So we're changing the way the wing shape is, some flaps, adding some other details. And then we start getting into some real concept art as to how we want this vehicle to work. So let's move on into Maya. So in this case here, I could take this, select this model, and I can just do the one-click send to Maya, and bring that over there and work with that mesh. So let's jump into Maya here. Here we go. And this is the exact same mesh here that we just brought over from Mudbox. Now, it's important to note that we're in Viewport 2.0, and Viewport 2.0 will handle PTEX. So this is PTEX Paint. Viewport 2.0 will support PTEX as well as several other renders now. RenderMan, Mental Ray, V-Ray, and renders are being added all the time. Other different rendering engines as well. So what we can do in here in Maya is take a look at the new modeling tool set. And these are really cool. We've actually taken, if you're familiar with the Next modeling toolkit, it's fully integrated into Maya now. So let's take a look at how that works. So again, highlighted in green here in Maya, you see the little icon up here. This is the modeling toolkit. I'm just going to click and turn that on. And now what I want to do, you can see that we know that the wing geometry has changed, or the idea for this wing concept has changed. So I want to change this geometry in here. What I'm actually going to do is set this mesh. I'm going to set a transform constraint for how I'm actually going to model on this. So I'm going to set my transform to be this retopoed mesh here. And then I'm going to turn on quad draw. So if you're familiar with any of the Next tool set, you'll know that this is a very cool, very fun way to work and generate a new mesh. And we talked about retopology in Mudbox. Here's another way to directly manually retopo a mesh here. So all I'm doing is I'm just clicking dots to represent the areas that I want my mesh to go. And by doing that, I'm defining areas where I want to add quads. And then by holding down the Shift key, I can just click add those quads on here. So here's another cool thing that we can do. If we just go in and drop down a bunch of these dots on here, and let's add in, let's see, I'm missing a dot in here. Put one right there. So we'll just add in all of these quads in here. Whoops. So I'm just shift clicking over top to add in those quads. And then what I can do with this, because I'm using the underlying mesh as a transform constraint, if I just hold down the Shift key, I can start to drop in edges. And you'll see that that mesh is going to hug to that original reference surface, right? So this is really powerful. If you want full manual control over quad by quad over top of a mesh for a retopo operation, this is excellent for that. So let's move forward here before Sean breaks out the cane. We took a look at how we can use a mesh as a transform constraint to work on a mesh here. I'm just going to jump ahead and reveal another surface in here. Just switch that component mode off. So we looked at how we can use quad draw to quickly draw quads on top of a mesh. We can also do another interesting thing. If I just select a mesh that I want to work with, I'll jump back into my modeling toolkit. And while that mesh is selected, let's turn off that transform constraint, because now I want this mesh to become my active mesh that I'm directly working with in here. So, yep. So now what I'm doing in this situation in here, I have let's clear dots down here. We have a little clear dot button. I can now go in and this mesh is now live. So just by shift clicking, I can easily fill holes in with that quad draw tool. And the nice thing about that is it's not just dropping in quads, it's merging and welding all those verts for me as well. So that's really nice. So that has now become part of the mesh, right? So that we actually have that as part of the mesh to work with. While we're in here, we have a new interactive bevel tool. You can see that when I'm highlighting over top of all of these things, I'm getting this really fast pre-selection highlighting. We've had that, of course, for a while in Maya. This one's a little different in the way that it's really fast, nice, accurate, clean feedback as I work. So I'm working with multi-components. In this case, I just want to, let's get out of the bevel tool there. I clicked that. I was too eager, Sean. So we'll just click the edges there. I'm going to define a couple of bevels along the edge of this wing. And then what we're going to want to do is just grabbing the interactive bevel tool, we'll just do this quickly. We can dial in how we want the offsets to be. We'll keep it at that. And then let's go back to our, let's actually use the new bridge tool here. So we'll just grab the edges in here. So I'm just going to, 30 seconds, what? Do I really? Okay, I'm going to jump ahead then. If you're telling me I really have 30 seconds, I'm going to show you something else really cool with quad draw in here. So, Sean, you can't kick me off like that. It's ridiculous. So, put back on here, constraint on here. This is another cool thing with quad draw. Since you're rushing me here, I'm going to move fast on this. So, in this case here, we now have this surface that we're working with. Actually, let me turn that one off because I want to, there we go, get out of that one. So I don't want to have that one selected. I'm just going to use that as a reference or a transform constraint. So now, same thing. I'm using quad draw, but another way I can work with that is if I hold down Control and Shift, you get this floating little widget. So I'm going to scale this poly up to the size I want, and I want to draw a frame for this cockpit around here. And I can just paint draw strips of quads, right? So I can start to quickly rough in the overall housing for this. I'm moving fast here. I'm just trying to move fast here, Sean. And then we can use the Shift key, of course, to go and fill in any of these spaces. And then we have another cool thing. While you're working live in this tool, because component mode is always kind of active while I'm working here, I can just middle click and tweak any of these components in here. So we can just grab faces, move them around, and we can use that to start to clean that up. What else are you not letting me show on here? Oh, one quick thing here. One quick thing that a lot of guys...
always one.
I know a lot of our modelers in a lot of studios, Pixar guys have been asking for this for years. If I want to insert an edge loop here, we can now do this in a number of ways. Almost all of these tools in the modeling toolkit, the next toolkit here, have multiple interactions. Multi-cut, for example, is slicing faces, it's splitting polygons, it's also inserting edge loops. So we saw we can do that with the quad draw tool. I want to show you something here. If we want to insert some edge loops on here, and I go back underneath my Edit Mesh menu, and let's just go to Insert Edge Loop tool to the options. You'll see now, by default, it's actually off. Usually, Insert with Edge Flow. And this is important because if we have this rounded engine housing here, and I click in that edge, it's actually going to follow the flow of that engine. So why is that important? Well, previously, you used to get a flattened across there. You were kind of limited to how you could work with that. And then I can come back and, of course, procedurally here, adjust that edge flow if I didn't want it to follow the contours between the other edges in there. So to be able to lock it flat.
Done.
And you're kicking me off now, aren't you?
I'm kicking you off now, yes.
Definitely check out some of the videos here. We got some videos going on with the retopology workflow in Mudbox. Lots of cool stuff there. There's tons of new tools in here. But of course, you're kicking us off. We can't
feel Craig's enthusiasm, though. He's like, I want to show you more.
Thanks, guys.
Excellent job, guys. And as we said, there's tons of other features in here. Check out online. Take a look. Ask us questions.